Good morning, everyone. My name is Nandini Tomar. I'm Assistant Professor in the Department of Computer Science and Engineering at IIMT College of Engineering, Greater Noida. So, in today's lecture, I'm going to discuss about instance-based learning in machine learning. So, first of all, these are the contents which I'm going to cover in today's lecture. We will first discuss about different ways of learning in machines. After that, I'll give you introduction about instance-based learning. Then we'll move to the different instance-based learning approaches. Then we'll discuss in more detail about lazy learning process. Under lazy learning, we'll discuss about k-nearest neighbor approach. After that, we'll discuss about some of the advantages and disadvantages of k-nearest neighbor. And then finally, we'll discuss about application area of k-nearest neighbor. So before discussing about different ways of learning in machines, I would like to explain you what a machine learning is. As we humans learn from experiences, in the same way we can also provide learning to machines by giving them historical or past data with which machine define a pattern or a model with which it makes future predictions. So this is the concept of machine learning. Now, based upon the ways machine utilizes the given data set, we have two machine learning methods. First one is model based learning and another one is instance based learning. Model based learning is learning by generalization. It means that machine provide a generalized model with the help of given data set for predicting the output of each new query instance. Under model-based learning, we have several models which includes support vector machine classifier, naive-based classifier, we have linear regression, logistic regression, decision trees, etc. Now coming to the instance-based learning. Instance-based learning is learning by memorizing. When a new query instance arrives, its relationship with previously stored examples are examined in order to assign target function value for the new instance. Now we'll discuss about some key properties of instance-based learning. First one is they are lazy learners. It means that initially machine does nothing. It just memorizes the given data set, and when a new query instance arrive for prediction, at that time it locally define a function for that target function for that particular instance and then make predictions. So that is why they are called lazy learners. Second is classification is different for each new query instance. Yes, just because as and when new query instance arrives, that time it locally define a target function and this process is repeated for each and every new query instance. That is why the classification is different for every query instance. Third key property is instances are represented in n-dimensional Euclidean distance. Now suppose we define our given data set in x and y plane and this is our target space. So for each new query instance, this instance-based learning approach, it assigns a target function and try to divide the target space into multiple different pockets, and these pockets are called polyhedrons, and put each new instance into one of the pocket based on the feature similarity. Now we'll discuss about different instance-based learning approaches. We have three instance-based learning approach. First one is radial basis function. Then we have case-based reasoning method. And the third one is lazy learning method. Under lazy learning, we have k-nearest neighbor and locally weighted regression. So one by one, we'll discuss in more detail about all these three approaches under instance-based learning. So first, we will take radial basis function. Radial basis function is a mathematical function whose value depends upon the distance from the origin, and this distance is called the radius. Further, machine use this radius to calculate the radial basis function and then finally make the predictions. Radial basis function are real valued functions and they use supervised machine learning to perform as a non-linear classifier. RBF is generally used for classification tasks, time series predictions, system control and function approximations in artificial neural networks. Now we'll discuss about some of the features of radial basis functions. First one is it is a three-layer feed-forward network. It means that it contains only three layers: input layer, output layer, and the hidden layer. And this hidden layer is also called radial RBF layer. Hidden node of RBF layer implements different radial basis functions like multi-quadratic function, inverse multi-quadratic function, or Gaussian functions. So how to calculate these functions? There is a formula in which we use that radius which we calculate earlier. These functions these are the functions of the radius. So it will be calculated as, if we talk about multi-quadratic function, so it will be calculated as phi r is equals to r square plus c square to the whole power 1 by 2. Then for the formula for the inverse quadratic multi-quadratic function is phi r is equals to 1 divided by r square plus c square to the whole power 1 by 2. Now finally, Gaussian function will be calculated as phi r is equals to the exponent of minus r square divided by 2 sigma square. RBF network is faster than simple artificial neural network due to its faster speed and universal approximation technique. RBF network perform well when it is required to fit the given data points to calculate the radial basis function, and this process is called interpolation. Now this is the RBF network architecture. As I said earlier, it contains only three layers. It is a three-layer feed-forward network. So the first layer is input layer where the input is passed, and then we have hidden layer where this radial basis function is calculated by using one of the formula I discussed in my previous slide. Then output layer where the final predictions are made. So this is the RBF network architecture. Now we'll discuss about case-based reasoning. In case-based reasoning, instances are not represented as real valued points. However, the instances are represented as the symbolic representation of instances are used. They are represented as a symbol or case with their solutions. Now the machine use these solved cases to solve a case with no solution. So case-based reasoning is an experience-based approach for solving a new problem. Case-based reasoning techniques solve new problem by retrieving stored cases, describing solution of similar problem, and incorporating their solution to fit new needs. So CBR relies on the fact that the more similar two problems are, the more similar their solutions will be. So by following this fact, the CBR uses already saved cases to solve their new case. Now we'll discuss how case-based reasoning method executes. First, we store the cases in the memory with their solution, and then to solve new problem, search and extract cases from memory with similarity situations. For this similarity situations, some similarity matrices are used, and similarity is assessed based on first the similarity of each feature value pair and or the importance of a feature. Next step is reuse existing case in the context of new situation. So in this case, either we completely use the previously solved case to solve a new case if it is exactly similar to the previous case, or we make some changes on already existing cases, or we adapt or adjust for differences. So after doing this adaptation and adjustment, we now have a new case with new solution. So this is the learning in this process, and now this solved case will be stored back into the memory or the case base. Next, we'll discuss about the case-based reasoning cycle. CBR is a model of learning and reasoning. It comprises of four main steps. First is retrieve, second is reuse, third is revise, and then final one is retain. So first, as defined in the given model, a new case arrives in the system. Then system retrieve the similar cases with respect to the given new case from the case base. After that, after retrieving similar cases, we move to the next step, which is reuse. So in reuse step, the system try to adapt the retrieved cases to fit to the new case. Now we move to the next step, which is revise. Here, the system evaluates the solutions and revise it based on how well it works. In between the reuse and revise step, a solved case, a proposed solved case, if doesn't work well, that it can be dropped out and the next solution will be checked. Then we move to the fourth step, which is retain. Here in this step, system decide whether to retain this new case in the case base or not. If system decides that we need to retain this case, then this particular case will be stored back in the case base. So this way, the complete case-based reasoning cycle executes for every new case. Now, if we talk about some of the use cases of CBR, so these are, first one is it can be used for conceptually designing of mechanical devices. This case-based reasoning can also be used to reasoning about new legal cases based on the previously rulings. So these are some of the use cases where CBR techniques can be used. Under lazy learner, we'll discuss about one of the approach, K nearest neighbor, which is in short called KNN. In KNN, K is the number of nearest neighbor of given query instance. When we make prediction at that time, when a machine make prediction at that time, machine consider the n nearest neighbor of the given query instance. Next, KNN is used for both real valued function as well as for discrete valued function. So it can be applicable for both type of given functions. KNN algorithm assumes that all the query points correspond to points in n-dimensional Euclidean space R to the power n. So KNN first memorizes all the given data set, and when a new query instance arrives for prediction, nearest neighbor of that query point is determined by using some distance measure, any one of the distance measure like Euclidean distance, we have Manhattan distance, Hamming distance, and many more. So we can select one of the distance measure, and with the help of that distance measure, we try to find out the relationship of the nearest neighbor of the given instance. Next, we'll try to understand the working of K nearest neighbor with the help of this example. We have some data set in which we have which is classified as blue circle and green circle. So we plot them in the according to the given graph. So here we have some blue circle as well as some green circle. Now we have a new query instance which we have defined with this red star in this example. So first we'll consider k is equals to 1. It means that we have to look for one nearest neighbor of this given query instance. So as the nearest neighbor of this given query instance have the blue belonging to the blue class. That is why we can conclude that this new query instance will also belong to the blue class. Now we'll consider another scenario where we have taken k is equals to 3. It means that now we have to consider 3 nearest neighbor of our given query instance. So in this case, the 3 query instances are defined by the given circle. So here out of 3, 2 belongs to the green circle class and 1 belongs to the blue circle class. So as majority of the nearest neighbor belongs to green circle class, that is why we can conclude that our given query instance will also belong to the green circle class. So this way classification is performed for the given query instance. Now we'll discuss the step-by-step execution of k nearest neighbor or algorithm of k nearest neighbor. So first of all, we load the data into the machine and machine just store the given training data set. After that, we determine the value of k. Now how to determine the value of k? For that, a cross validation is done by putting different values of k, and after that the value of k which gives best result is selected. And we always consider the value of k as odd number, and it ranges from 1 to 18, 17. After determining the value of k, we estimate the distance between each training point and new data instance by using any one of the distance measure which I mentioned earlier. So here in this case, we are considering Euclidean distance for measuring the distance between the query point and the given data set. So if P1 and P2 are 2 points, so in this case Euclidean distance will be calculated as d is equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square. After calculating the distance, we sort the distances in ascending or descending order. After that, we collect the label of nearest k neighbors. It means that we collect the labels of the nearest neighbor of our query instance. Then finally, we choose the label of majority of the neighbors as the label of new query point if it is a classification type problem, and if it is a regression type problem, and so in that case we return the mean of the nearest neighbor. Next, we'll take an example to understand the working of k nearest neighbor. So in this example, it is in the table below, marks of 2 subjects are given, and on the basis of marks mentioned in mentioned subjects, it is determined that whether a student will get admission in a university or not. By applying KNN algorithm for k is equals to 3, we will determine a new student with 6 and 8 marks in maths and science subject will got the admission or not. So our new query instance have the value 6 and 8, that is the marks in maths and science subject, and here the value of k is equals to 3. It means that we have to consider the 3 closest nearest neighbor of our new query instance, which is the student with marks 6 and 8 in maths and science subject in this case. So this is our new query instance. We have to find out the label whether he will get the admission or not, yes and no. Okay, so first we'll calculate the Euclidean distance by using the formula I mentioned earlier in previous slide. So we have calculated the Euclidean distance. Then we rank them. First is 1.41, second is with the distance 2, and third is with the distance 2.23. Here we have considered 3 nearest neighbor of our given data set, query data set. Okay, so all these nearest neighbors belongs to yes class, so we can conclude that a new query instance or the student with the marks 6 and 8 in maths and science subject can also get admission in the university. So this way K nearest neighbor works. Now talking about the application areas of K nearest neighbor. So KNN algorithm is used in recommendation systems like Amazon and Netflix use KNN to recommend product or media to their customer. Next, KNN can be used for document classification. It is also used for recognizing patterns. It can assist in detecting and spotting suspicious patterns in credit card usage. In medical diagnosis, KNN is used to find similar disease structure and patterns of a patient. KNN is also used in facial recognition and identification systems. Now coming to the advantages of K nearest neighbor. First is no training is required. As K nearest neighbor is a lazy learner, it means that it does not require any training, which makes it much faster than other learning based system. Next, it is easy to understand and simple to implement. Here we just need two parameters, that is value of k and the distance function. With the help of these two parameters, we can easily locally define a target function for the given query instance and then make predictions. So this is the simplest approach. We just need to have label data set and value of k and the distance measure. It can work with both classification as well as for regression type problem. It can easily handle multi-class classification, or not. It is not limited to binary classification. We can apply this method in multi-class classification as well. It constantly evolves with new data. Now talking about the disadvantages of k nearest neighbor. First is it is computationally expensive. In K nearest neighbor, as the size of training data set increases, more the computation will be required, because here we calculate the distance between the query instance and the all data set in the training data. So that is, in this case, huge calculation will be required, and this way it becomes computationally expensive. Next, it do not work well with high dimensional data, because with large number of dimensions, it becomes difficult to calculate distance in each dimension. So that is why it do not work well with high dimensions. Next is it is sensitive to noisy data, as we need to remove noise and add missing values manually, because it is very much sensitive to missing and noisy data. Next is it needs require feature scaling. Some standardization and normalizations of features is required before applying k nearest neighbor to any data set. Otherwise, wrong predictions may be generated. So these are the some disadvantages of k nearest neighbor. So that's all for today. I hope you all have a good learning session with me. Thank you so much.